Here I will use PlateLogic to perform a data array analysis, and I will use tags to help filter the results. Firstly, to help identify our tags, I will move the tags column right up next to the file name. In their simplest form, user-defined tags can be added to one or a selection of files by highlighting, right-clicking, choosing tag and adding new tag. And for example, we could call this Group A. Likewise, I can select a new set of files, right-click, choose tag, add new tag, and this could be Group B. Now, if we right-click in the file inspector, choose tag, filter, and Group A, we can display just those samples in Group A. Now, if we right-click, choose tag, and set our filter mode to any tag, and then select Group B, we can display only the files that are in Group A or Group B. It is also very easy to clear all filters. PlateLogic also has a range of more advanced auto tags, which can be particularly useful when performing data array analysis with heat maps. To produce a heat map, select PlateLogic from the Advanced Functions pull-up drawer, click in the Plate window and select New Plate. Then, highlight all of your files and drag them into the plate, and you will see PlateLogic automatically generates a heat map. To help analyze all of these files, I will also place them in a group. Opening the Plate side drawer reveals a number of tabs, the first being the Plate Setup tab, the rest being the heat map settings, statistics, plot viewing, advanced functions, and outlier detection. Double-clicking on a well will open the corresponding sample in the workspace, and this can then be analysed just as you would any other sample. So here, I will arbitrarily draw a gate on these two parameters, and as this file is in a group, this gate will automatically be applied to all other samples in the group. Back in the Plate side drawer, I will change the well shape, and in the Heat Map Settings tab, I will choose this new gate and change the statistic to percentage of parent, and you will see a new heat map is automatically generated as the automatic heat map setting is on. Of course, the user can customize the heat map by turning off the automatic setting, double-clicking in the value column and typing in a new value. So as you can see, this could potentially be a very useful way for identifying samples that sit above a particular threshold. These results can be displayed under the Statistics tab in a table that can be coloured to match the heat map, and this colouring will be exported with the tables if they are displayed. These results can also be displayed in columns, which again can be coloured to match the heat map. Comments can also be added to individual samples. In the Plot Viewer tab, individual dot plots or histograms can be viewed simply by hovering over the wells, but the plate itself can be set up to display plots rather than the heat map colours alone. And this is done by right-clicking in the plate and choosing Show Plots. And this can be in the form of dot plots or histograms. And these can also be coloured to match the heat map colours. Where auto tags can become useful is when we only want to display particular samples that sit in a particular range in the heat map. To apply the auto tags, right-click anywhere in the file inspector, choose Tag, Auto Tag, and in this case, Plate Heat Map. And you will see the corresponding heat map colour has been assigned to every sample in the list. Now we can apply a filter to display only those samples that sit within a particular range in the heat map, in this case, those coloured red. And here we have those 20 files that sit within this range.